In this video, we're going to explore the first of our special quadrilaterals. The trapezoid is a quadrilateral with at least one pair of parallel sides. Now, this whole notion of at least one pair means it could have one pair of parallel sides. It could also have two pairs of parallel sides. A little bit of vocabulary that you need to be aware of: if only one pair of sides are parallel, then those parallel sides are called bases. So in this picture here, the bases happen to be the top and the bottom of our trapezoid. The non-parallel sides are called legs. So in this trapezoid, the legs are the left and right. Some other vocabulary you need to be aware of regarding the trapezoid is the median, which is sometimes called the midsegment. The midsegment is parallel to the two bases, so the median would be parallel to the two bases, and has length that's equal to half the sum of the lengths of the two bases. So in other words, the length of the median is the average length of the two bases. So in this particular case, the length of median MN is equal to 1/2 the sum of the two bases, so the sum of DC and AB. And again, think about that as taking an average of the two bases. Now, anytime we're working with this median formula, we're always going to write the formula down. That'll take these sometimes tricky questions and make them a lot more manageable, a lot easier to solve. So always write that formula down on your paper. That's important to know. A little bit of more vocabulary that you need to be aware of: an isosceles trapezoid is going to be defined to be a trapezoid whose base angles are congruent. Anytime you have an isosceles trapezoid, the legs are also going to be congruent, as will be the diagonals. And the diagonal of a polygon is just any segment that connects non-adjacent vertices. So in this picture, segment DB and segment AC would be the congruent diagonals. In this picture, the congruent legs would be segment AD and segment BC. All right, so let's go ahead and take a look at some examples where we can put our newfound knowledge here to work. In this first problem, they're giving us this trapezoid and asking us to find the measure of each angle. Well, our parallel bases are AB and CD, and we're going to use our knowledge of parallel lines to set up and solve and find the other measures, or the measures of these other two angles. So if I take and extend the two bases, and I think or consider AD to be a transversal, I know that the angles on the same side of that transversal are going to have to be supplementary. So if I call or label this one X, I know that 78 plus X has to sum or total to 180. So in other words, X is 102. Next is the measure of angle D. So the measure of angle D here is 102 degrees. I can use a similar approach over on the other side of the trapezoid to find the measure of angle B. So I know I'm going to call this one Y. I can't call it X because I already used X for a variable. So Y plus 132 degrees, because they're same side interior angles on parallel lines, they have to total 180 degrees. So Y ends up being 48 degrees. Or in other words, Y is the measure of angle B. Note that this trapezoid is not isosceles because it does not have congruent base angles. All right, the last question on this page has to do with midsegment MN. So anytime we have the length of a midsegment, we know that the length of that midsegment is equal to the average of the two bases, or in other words, half the sum of the two bases. And we always start by putting the formula down on our paper. So midsegment MN is equal to half the sum of the other two bases. So base ST plus base RA. And now that we got the formula down on our paper, now we're going to go ahead and substitute some numbers and values into that formula. So from the picture, the length of midsegment MN is 19, so I'm going to substitute that into my formula. I'll drag the half down to the next line, and you're going to want to do that on your paper at home as well. ST is 4x subtract 7 plus RA, whose length is 6x plus 5. And now I'm simply going to solve the equation that results. So 19 equals a half. I'm going to clean up what's inside the parentheses. So when I combine the terms with an x on, then I find that I have 10 x's minus 2. Now I can go ahead and distribute that 1/2. I'm going to add 1 to both sides. And the value of x is equal to 4. Since what I was being asked to do in this question is find the value of x, I know that I'm done. But again, the very important thing about this question, make sure you put that formula down on your paper because it will make the problem so much easier to solve. Okay, the last type of problem you might see involving a trapezoid is the proof. So to prove that a quadrilateral is a trapezoid, we must show that it fits the definition. In other words, that it has at least one pair of parallel sides. In the coordinate plane, we can show that the sides are parallel simply by showing that they have the same slopes. If we're trying to prove that the trapezoid is isosceles, we either need to show that the base angles are congruent or that the diagonals are congruent. Either one of those conditions will force our trapezoid to be isosceles. So I'm going to go ahead and get into this, and I think I'm going to start just by proving, first of all, that the quadrilateral is a trapezoid. So I'm going to go ahead and plot the points so that I can get a visual picture of what it is that I'm working with here. So there's my quadrilateral. And again, in order to show that it's a trapezoid, I need to show that it has one pair of parallel sides. So looking at the picture, it's pretty clear that the pair of parallel sides, or the pair of sides I'm going to prove are parallel, are the top and bottom of my trapezoid, side AB and side CD. And the way that I'm going to do that is by use of the slope formula. So like any other formula, if I want to use it, the very first thing I need to do with it is get it down on my paper. You need to get it down on your paper also. So slope is equal to change in y over change in x. And the first segment for which I'm going to find slope is segment CD. So I'm going to tell whoever's reading my paper, I'm finding the slope of segment CD. So the slope of segment CD is going to be 2 subtract 2 over 9 subtract 2. And I can get my calculator out and punch this whole fraction into my calculator. When I do, I find that the slope of segment CD is equal to 0. And then I'm going to go do the same thing, but this time for the other base, segment AB. So when I find the slope of segment AB, slope here is going to be -4, subtract -4 for the numerator. And then for the denominator, 1 subtract 10. And when I get my calculator out and punch in that fraction, with -4 subtract -4 in the numerator, 1 subtract 10 in the denominator, my calculator tells me the slope is 0. So now I'm going to write a little blurb saying why my quadrilateral must be a trapezoid. Anytime two segments have the same slope, they are parallel. So that makes segment AB parallel to segment CD. This quadrilateral is now a trapezoid. Because it has one pair of parallel sides. So the first part of that problem is now done. The second part, proving that it's isosceles, I either need to accomplish by showing that the base angles are congruent, and because I'm in the coordinate plane, I really don't have a way to show whether the base angles are congruent or not. But the second method I could use is to show that the diagonals are congruent. The diagonals, remember, connect non-adjacent vertices. So go from one side of the quadrilateral to the opposite or kitty corner side. So my diagonals in this particular trapezoid are going to be DB and AC. If I could show that those two are congruent, my trapezoid would have to be isosceles. So the formula that I'm going to use to show that they're congruent is, of course, the distance formula. And of course, if you're going to use a formula, the very first thing you need to do is write it down on the paper. You're going to write it down on your page as well. And I'm first of all going to go find the distance of diagonal AC, but it really doesn't make a difference which diagonal you choose to do first. And this I wouldn't do without the help of my calculator. I would type all this into my calculator here. My calculator tells me the square root of 100, which I know to be 10. And then I'm going to go do the same thing, but this time for diagonal BD. So square root of 100 then is also 10. So now I have to write a little blurb explaining why my nice nifty little calculations make this trapezoid isosceles. So this trapezoid is isosceles because its diagonals are congruent. All right, so with that said, I'm going to call it quits for the day. As always, I want to thank you for the gift of your time and paying attention to and watching the video. I do want you to, as always, take a few minutes to think about and reflect on what you've seen in the video. And what are going to be the most important ideas and the essential understandings that you're going to need to bring with you the next time that you come to class.